Today I'd like to present an introduction to the nomenclature of alkynes, and I'm also going to include a functional group priorities chart as one of the last slides. The priorities are important to know so that you know whether or not to name a particular functional group as a prefix or a suffix if multiple functional groups are present in a molecule. It also helps you determine how to number the compound to give the highest priority functional group the lowest possible number. Now, you've already seen videos, I hope, on nomenclature for alkenes, alkyl halides, alkenes, and even the stereochemistry videos in which we talked about RNS and E and Z stereoisomers. Naming the alkynes follows the same general rules that we've already seen. We'll find the longest continuous carbon chain that contains the carbon-carbon triple bond to determine the root name of the molecule. We'll number the alkyne so that the triple bond receives the lowest possible number, and then we'll use the same rules that we've seen already for naming substituents like alkyl groups or alkyl halides. So let's take a look at this example. If you recall from one of the earlier videos, we said that we choose the longest continuous carbon chain in which there are more branches. So that's this one. As I look at the name, I know that the root is going to be a hept. So I'm just writing out parts of the name. I know that the alkyne is going to be on carbon 3, so 3-ine as part of the name. Looks like I'm going to have a 5-ethyl as a portion of the name, and a 6-methyl. So when I put that all together, I'll put it in alphabetical order: 5-ethyl, 6-methyl, hept, 3-ine. Notice that there are hyphens between numbers and letters, and there are no spaces in the word. When multiple alkynes are present in the same molecule, the suffix changes to a diine, a triine, a tetraine, etc. For this molecule, it's numbered right to left to give the alkynes the lowest possible number. In other words, they're on carbons 1 and 3. I know a portion of the name is going to be pent, and I know that I'm going to have 1,3 and diine in there somehow. And so that's actually all put together by saying penta 1,3-diine. Notice that there is a comma between the two numbers. Again, hyphens between numbers and letters. This is all one word. Now you may also see it written as 1,3-pentadiene. That's the older style nomenclature, but it's still acceptable. If you have alkenes and alkynes present in a molecule, you'll name them as ene-ines. Note for the ene-ine suffix that you delete the extra e in the ene portion of the name. If there are multiple alkenes or multiple alkynes present, you simply change the suffix to a diene, a triene, or maybe an ene-diine. You'll notice that the e goes back in when there would be two consonants together, so we have to reinsert that e to have an ene-diine. Now, alkenes are technically higher in priority than alkynes, but we do number the chain to give the multiple bonds the lowest possible numbers. So if there's a choice, we give the alkene a lower number. In the first molecule, if I give the alkene the lowest possible number, then I number right to left, and I have an alkene on carbon 1 and an alkyne on carbon 4. If I were to number it the other way, I would still have multiple bonds on carbons 1 and 4, so I'm giving the alkene the lowest possible number. This would be named as a pent 1-ene 4-ine. For the second molecule on the screen, I have to decide whether to number it left to right or right to left. If I number right to left, then the multiple bonds get lower numbers. I have a 1-3 multiple bond substitution pattern, not a 2-4 that I would get if I numbered from the other end. So in this case, the alkyne is given the lower number. So this is going to be a pent 3-ene 1-ine. Here's one for you to try. I very much encourage you to pause the video and give this one a name. Don't forget to actually write out your answer. So let's work out the solution. First, we need to find the longest continuous carbon chain, and that's here. The other chain is the same length, but I've got the alkene and the substituent bromo on this portion of the chain. Then I decide whether to number that chain left to right or right to left it turns out that I would have a 2-4 substitution pattern writing in either direction. So I'm going to give the alkene the lower number. So I number it right to left based on the alkene getting the lowest possible number for the multiple bonds. So now when I look at a portion of the name, I know that I'm going to have a hex. I know that I'm going to have a 2-ene, and I'm going to have a 4-ine. I'm going to have a 1-bromo, and I'm going to have a 3-ethyl. And in addition to that, the stereochemistry of the pi bond is clearly shown, so I'm going to have to determine whether this is an E or a Z alkene. Let me write out the name that I have so far, and we'll go back and determine the E or Z stereochemistry. The substituents are listed in alphabetical order, so I have 1-bromo, 3-ethyl, the root is a hex, and then I list the 2-ene and 4-ine. 1-bromo, 3-ethyl, hex 2-ene, 4-ine. Now let's go back and look at that alkene and determine whether it has an E or a Z configuration. When I look at the substituents on one side of the alkene, I have an H, which is going to be the low priority group, and I have a carbon, which is going to be the high priority group. And when I look at the substituents on the other side, I have a carbon bonded to a carbon and 2 H's, and I'm comparing that to a carbon that is bonded as a triple bond, which counts as 3 bonds to carbon. This is going to be my high priority group, and the ethyl will be my low priority group. The high priority groups are across from each other, and that makes this an E alkene. So completing my nomenclature, I have to put an E up front. E, 1-bromo, 3-ethyl, hex 2-ene, 4-ine. Now let's go back and talk about some of the common names. It turns out that the simplest of the alkynes is referred to by the common name acetylene. So its IUPAC substitutive name would be ethine. That name's hardly ever used. Acetylene is very commonly used for the smallest of the alkynes. You can name alkynes as substituted acetylenes. So for instance, the terminal alkyne phenylacetylene is shown on the left, and the internal alkyne is named by naming the substituents methyl and ethyl, putting them in alphabetical order: ethyl, methyl, acetylene. Now it turns out if you have a higher priority functional group present, you'll need to name the alkyne as a prefix, and it's an alkynyl substituent. So I'm showing the structures of ethynyl, 1-propynyl, and 2-propynyl groups. Now we've already seen that the common name of the molecule shown at the bottom is phenylacetylene. Using the alkyne prefix, we can also name this as ethynyl benzene, which is a systematic way to name the molecule. Now here's the chart of functional group priorities that I promised. This chart will be important as you continue to learn how to name organic molecules containing a variety of functional groups. You'll notice that the functional groups have both prefix names and suffix names. The alkenes and the alkynes are named typically as suffixes, but many of the other functional groups can be named as either a prefix or a suffix. You'll see later how these functional groups are named. I used a number of resources to create this video. The Wade Organic Chemistry text is a sophomore level organic chemistry textbook. Roberts and Caserio actually have a full chapter on organic chemistry nomenclature. I also referred to the Journal of the American Chemical Society paper by the International Union of Pure and Applied Chemistry for their definitive rules for organic nomenclature. And if you don't know already, ChemDraw and ChemBioDraw can be used to help you name compounds. You simply draw the molecule in the program and then ask the program to assign a name for the compound.